All right, so welcome to Night Hacking at Devox. I'm joined with James Ward
Hey everybody, this is James.
from the cold North Tundra, apparently.
It's freezing in here, man. I need like 3 jackets, and we're inside.
Yeah, so it looks like sessions just got out, so I think the body heat will quickly warm us both up.
Let's hope so.
All right, so we'll do a little bit of hacking on Play and Scala, but before that, why don't you talk a little bit what you're doing at the conference here and what sort of things are happening in Scala land?
Yeah, so great to be back at Devox. I missed last year, but I think this is like my 7th time here or something, so pretty awesome. It's a great conference. So this year at Devox, I had a Play and Scala hackathon, well, I guess it's more like a lab. We told them what to do. We didn't let them do anything. So yeah, and then we had that. It was 3 hours. Everyone, I think, got the app working and everything. It was WebSockets and all sorts of cool stuff. So that was fun. And then yesterday I did an impromptu Akka talk with Josh Surratt because one of our coworkers got sick and couldn't do the talk. So it's like, hey, you're on. Oh, okay.
Was that Jonas or someone else?
That was Ryan Knight. Unfortunately, he's still here, just a little sick. So, yeah. And then today I had a WebJars quickie, and WebJars is a way to package up the JavaScript and CSS libraries from the web and make it easy to pull those into a Java web application. So, so did that. That was fun. And now I'm here doing this and going on a brewery tour later. So that's my plan for Devox.
Oh yeah. I'd love to go on the beer tour, but I'm going to be stuck here doing a chest bop. So enjoy the wonderful Antwerp beer.
Well, I hope you win. That'll make it worth it.
So this is not a win-lose. This is a show the big toy we showed on stage today and hope it doesn't crash. It's the chess demo for Java.
That'd be winning if it doesn't crash.
All right, cool. So if you're joining us live, pop in chat, say something to us, and we'll be happy to take Q&A. The videos obviously are on nighthacking.com, and I'll also be putting them on Parlays and the Java YouTube channel and various places. And we're gonna get to some hacking. So let me pop up your desktop here, and we're now, you can see us in the corner there, hanging out.
Awesome.
So what do we got? What's this thing you got here? Typesafe Activator.
Yeah, so Activator is a tool that we created at Typesafe to get people started building applications with Play and Scala. So you just download it from typesafe.com. It's open source, and then you can start building apps, and that's what we're going to do.
Okay, let's build an app.
Let's build an app. So in Activator, you can choose from the templates that are here. You can also go explore a bunch of community-contributed templates. I'm going to go find one that's the Play framework Scala-only one, because we're just going to be doing some Scala today. And I'm going to say, all right, let's put this thing on my desktop. So I'll select that folder and then hit Create. So this is just creating a copy of that template application, and then we'll be able to go in and start editing some code and making some changes to the app, and then I'll open it up in IntelliJ, and we'll be able to do more with it there. It's going to resolve some dependencies and stuff, so it'll take a second the first time it loads this app up. So there's a lot of different templates you can choose from inside of Activator. There's Play ones, there's Akka ones, there's Scala ones, really Java ones, Scala ones, really a big variety of different templates to start with. So.
Oh, and there we are.
And there we are. So in Activator, we have a tutorial for every template, so you can read about the code, learn about how it goes. This one is apparently under construction. That's my fault. I need to finish writing the tutorial for this app. But that's okay. You're going to get your tutorial live. So, so this is the Activator UI. And in the Activator UI, we can go browse through the code. So we can go in and see, like, all right, here's my application.scala. We can go and see the compile output. It's going to run the test for us, and then it's going to run the actual application. So this application is a web application. It's up and running on localhost 9000. So we can go in there, check it out. Here's our pretty little app that we just created. So before we start working on it, I'm going to open this thing up in IntelliJ. So I need to generate some project files, and that'll take a minute to do that. So while it's doing that, I'll talk a little bit about Play Framework and what it is and what's
Yeah. So for folks who've never ever touched a JVM language, what's this Scala stuff? That was the dumb interviewer question. I'm trying.
Thank you. I have been asked a couple of times at Devox what Scala is, so it's not a dumb question. Scala is a programming language that combines object-oriented and functional programming. So you can do both. You can do either, up to you. And it's, of course, based on the JVM. It has interoperability with Java. It has some really nice features, like it has a concept for being able to do asynchronous stuff. And that's part of what we're going to be taking a look at in a few minutes. And then Play Framework is a web framework on the JVM as well. With Play Framework, you can use Java and you can use Scala, totally up to you which you want to use. And it's a modern web framework, so it supports things like WebSockets and asset compilers for less and CoffeeScript and those sorts of things.
Yeah, so I heard the Play team was quite excited about getting Lambdas in Java finally, so they can stop maintaining really old patterns for one half of it.
Yeah, the challenge with all this async and non-blocking stuff is that we need to do callbacks essentially, and hopefully we do those callbacks in a non-blocking way. I guess that's essentially what a async construct is for. And so Java today, pre-Java 8, just doesn't have a very good way to do essentially a callback. And so you have to do these nested inner classes, and it's just a little messy. IntelliJ makes them look prettier, though. It's kind of nice. They collapse them down into like a Lambda-like syntax. But anyways, without IntelliJ, it's kind of nasty. And so that's one of the reasons why I'm writing this code in Scala today, is just because it shows the what I'm trying to show, the async and non-blocking stuff, a lot more concisely. But when we get Lambdas in Java 8, then we're going to be able to really make the Java API for Play and the way that you do functional programming or do work with async stuff in Play, make it really nice. So it'll be awesome. We're definitely
cool, very nice. So how's our IntelliJ project doing?
Yeah, let's go open it. So the project files are created. Let's go open it up here. So this is on my desktop, and then it's this Activator Hello Play. So let's go open this thing. And I said open. Let's try this again. Desktop. Hello Play. Oh, I picked the wrong one. There's like a weird caching thing in IntelliJ. Okay, now we're good to go. Okay, so this is going to take a second to index, but while it's indexing, let's go through some of the stuff that's going on in this application. So first, let me start with the conf routes file. In Play, this is the way that we map an HTTP verb to a path, and that path can be parameterized RESTful style. And then the controller that's going to handle that request. So in this case, I'm calling controllers.application.index, just a static method essentially on that thing. If you want to use DI, you can do that in Play as well. You can throw in any DI framework, and instead of calling a stacked method, you can go to your container and get your instance out and call the method that way as well. So that definitely works. So let's go check out the code for that. So here, app is our main source directory for Java and Scala. We have a controllers package, and then here's our application.scala code. So in this case, here's my method index that is going to take a request and return a response. That's really the major thing that a controller method does in Play, and it's all stateless. So everything is take a request, return a response. So in this case, we're wrapping this thing up into an action. Really, an action is just a wrapper around a function that actually a literal function that takes a request and returns a response. So in this case, I'm not actually doing anything with the request, so I don't have to specify it. And then my response is status code 200, so I say OK. And then I'm going to use a server-side template in Play, which is down here in views. So index.scala.html gets compiled into this server-side template. And then that's what actually is going to render this web page that we see here. Yeah, so that's our basics. So now let's do some more exciting async and non-blocking stuff. So I'm going to just remove what we have there, and instead, I want to show how we do async and non-blocking. And there's a few different ways to show this. I could kind of start at the beginning, but let's just skip to the exciting part. So
I want to skip to the exciting part.
Yeah, and the boring stuff is boring. Yeah. So one of the things that we can easily make async and non-blocking is requests to websites. So there are things that are not very easy to make blocking. For instance, talking to a relational database. most databases, relational databases, don't have a way to not block because JDBC doesn't have a way to not block, and the database vendors, drivers don't have a way to not block. So everything is just blocking. You block a thread until you get your result back. Just the way that it is, but there are some things that are easy to not block on. One of these is making a web request. So when I make a web request, what it means to be non-blocking is when I'm not actually transferring data, I don't actually need to use a thread. So if I'm just waiting on the other side to respond, when I'm just waiting for the website that I'm calling to respond, I can actually take the thread and give it to somebody else, and then when I get the response and I need to transfer data again, then I can get a thread back and do something with the response. So, but in that period of time when I'm just waiting, I don't need to have a thread allocated. This is all enabled through Java NIO, is really the way that we do this.
Cool, yeah.
Okay, so what I'm going to do is create a web service request, and I'm going to do it to jamesward.com. So I'm going to do WS, and this is using Play's web service client library, which is async and non-blocking. And I'm going to set the URL here to, let's just go to my website, jamesward.com, and then I'm going to make a GET request. So that's actually like an HTTP GET request. So this GET request, this GET method, what it actually returns is not a response. It returns a future of a response. And the future is the Scala API for doing async things on another thread. And so this will actually now schedule this request to be made. When I can give a thread to this thing, it's going to make the request. And then while I'm waiting for the other side to respond, it's going to take that thread, give it to somebody else. And then when I get a response back, it's going to get a thread. And then it will fulfill the future.
Very nice. So all asynchronous and happy.
Exactly. So the challenge here is that I need to make a few more changes to this controller in order to support this. First is that the default action wrapper around something, it takes a function that returns a result. So when I had that OK, that was the actual result. In this case, I don't want to return a result because that would be blocking. What I instead want to return is a future of a result. So something that will in the future produce a result. So to change that method definition, I just need to put in action.async. So now, one last thing I need to do is that this JWF variable here, that thing actually is a future of a response, and what I need back out of this controller is not a future of a response, it's a future of a result. And I'm not really sure why we have two different things, a response and a result. They're pretty similar, but we do for some reason. So I need to now take this future of a response and turn it into a future of a result. So the way that I do that, to transform the thing inside the future, I do a map. So this is functional, some fun functional stuff here. So I'm mapping, which is taking the thing in the middle, the thing in the future, and transforming it. So in this case, I'm just going to take my response. That's what's inside of this thing when it completes, when that future completes. And now I need to create a result. So I'm going to do OK, and then I'm going to just return response.body, which is a string, just the string of my web page. So now it looks like everything is happy. I can just go back to my browser and hit refresh, and then one thing we need is that we need to tell these futures how they actually run on threads. And so in Scala, there's an abstraction on top of thread pools called an execution context. And so in order for this thing to work, we need to provide an execution context.
Yeah. Having errors in your hacking, this is an important sign that we're actually hacking.
This is real, man. This is real.
If you write unit tests and they never fail, do you know what they are? They're not unit tests.
Nice. Okay, so let's import the execution context. There's one is in Scala concurrent execution context, implicit global. So this is an execution context. It's just the default. I think the default number of threads is like 1 plus your number of CPUs on your machine, and then it uses fork join. So it's just a basic one. We can declaratively configure it, add more threads, do whatever we need to that. We can also create our own execution context, but we'll just use that one. And this is getting maybe a little Scala-y, but I do, the way that I'm actually providing this thing is through a Scala implicit. So.
Wow, implicits. Those are fun.
Implicits. Those are fun. So now when I hit reload in my browser, my compilation error goes away and we see my web page. I didn't set the content type, and because I just gave it a string, it just said, hey, you're probably talking about text plain here, so didn't set it. So now we're just seeing my web page as a string.
Very nice web page. Very professional. You should make this your new blog.
It looks beautiful. So now the cool thing about this is when I load this, you'll see there's a little bit amount of time where the browser is spinning. So I have a request from the browser to my Play server, and I have a request from the Play server to jamesward.com. And there's going to be some amount of time where I'm just waiting for jamesward.com to respond. And in that amount of time, those two threads that would normally be allocated and just in a wait state, those two threads go off and can handle somebody else. So this is async and non-blocking.
Nice. It gives you a lot of scalability and parallelism and all the stuff which makes your boss happy, I guess.
Exactly. So I want to take this one step further, and then we can chat about whatever.
Okay. Yeah, let's do it.
Cool. So a lot of times in our when we're talking to services in the back end, we need to compose together a bunch of different services. So I want to add in another service and then show you how we can do the composition in a pretty sexy way. So what I'm going to do is come back into the code, and I'm going to create another future, and this one is going to be to Twitter instead of jamesward.com. So this is I'm just working with HTML data. Obviously, we'd be using JSON or XML here, or something else. So I'm going to create these two requests, and now what I want to do is compose together these two things, and I want to do it all async and non-blocking. So there's a for comprehension in Scala that's a really nice construct to do this. So what I can do in the for comprehension is I can say, all right, take that JW future, and I want to get out of that its value, and then I want to take that Twitter future, and I want to get its value out. And when that stuff is all done, I'm going to now yield a response, which is going to be my status code 200 response. And now I'm going to take my JW body, that's just my response body to do the Twitter one first, and then I'll get the body from JW dot body. So we're just putting those together. Obviously, this is a horrible use case since we'd probably be working with JSON data and munging these JSON structures together and doing something more important with them. But the cool thing about this is that this for comprehension, it's async and non-blocking. So the for comprehension actually returns a future of a result because it takes whatever the thing is in here, which is the future of something, and it now essentially wraps up this yield, wraps up the thing that I'm yielding into a future as well. So I'm now going to have two web requests going out, and both of those will probably be in a wait state at some point in time. So I would normally have 3 threads allocated to handle this request. So the thread from the browser to the server, and then the 2 threads from the server to one to James Ward and one to Twitter, right? And so in this case, 3 requests, and all of them can be async and non-blocking. So let's go try it out. Let's just make sure it works here. So I'll refresh in my browser, and Play will recompile the change, and then now we're seeing Twitter. So this is the text for Twitter, and if I scroll way down, we see the text for James Ward. So now I've just done that whole thing async and non-blocking.
Very cool. Very cool. So that was some nice on-the-fly hacking, showing what you can do with the Play framework in Scala. So what else should we talk about? What else you have up your sleeve?
Oh, what else do I have up my sleeve?
Any vacations coming up?
Actually, my wife is meeting me here. My wife is meeting me here in Europe on Friday, and we're going to go up to the Alps for the weekend and go to a spa. So that'll be a nice little.
That's nice. That's nice.
After
so you're going to Switzerland?
Yep.
I guess the Alps technically span a couple countries, but
yeah,
the Swiss Alps.
Yeah, we're going to the Swiss Alps because then I'm going to spend the week at the Typesafe office in Lausanne, Switzerland. So,
Nice. That's where the is it EPFL, EFPL,
right,
EPFL, where oh man, I'm losing it. Yeah, where Martin works.
Yeah, it's that jet lag kicking in, or the lack of good coffee.
Or the fact I gave 6 hours of presentations yesterday, plus a keynote this morning, plus 4 hours of interviews today.
Dude, let's go get a beer.
Yeah. So we were talking about that, and yeah, you'll be going to beer tour, and I'll be in the chess spa manning the robot. Yeah, it'll be fun.
Yeah. I'll bring you a beer.
Yeah, and see, I even left us doubling up on the screen there. That's how jet lagged and tired I am.
That's how we roll. There's actually 4 of us. Those are our clones back there. Hi, clones.
Yeah. I killed them.
Oh.
We also got the naked dude behind. We can feel up.
Oh, that sounds like fun.
All right, cool. So I actually have something for you to celebrate your your first in-person night hacking episode. You did the interview before Java 1, but night hacking sticker, and it's transparent. So
how does it work on a ThinkPad?
I think it will work wonderfully because it'll be black in the background. Shh.
Wonderful. Thank you so much. I'm a night hacker.
Better watch out. I'm going to make you sing the logo for our new show.
Yes, please.
All right, and so for folks who haven't heard, we're going to start a new regular broadcast every first and third week of the month on Thursday mornings. Thursday morning specific, Thursday evening, time out here. So look forward to that starting in January, and our first guest will be Brian Getz on January 16th.
Nice. I'll be there. That's awesome.
So speaking of Brian, I've seen him around the conference somewhere. Maybe he'll join us for a talk in a little bit. I'll see if I can snag him at 4 o'clock when he's supposed to show up.
Nice. Yes.
All right. So thanks again, James. Stay on the stream if you're joining us live, and goodbye to folks watching the recording.